Hey guys, this is Steel Bro, and today we'll design a steel composite building in Tekla Structural Designer. So we'll follow all the steps. First of all, you need to click on New. Okay, so the new project will open, and before that, if you want to, just change the country settings in according to which you want the steel sections and all, you can change it from the settings. And if you want to change the, project codes and all, you can change it from here. You can design by all these codes, UK codes, US codes, or any code of your country from here. Currently, we are doing by the Indian codes. Okay, so let's get started. First thing we need to do is go to models and click on construction levels. So I have a brief, description of the floor which we will do here. So we'll do, a 3 meter floor to floor height, and at the top we'll provide a kind of truss, this beam, this slope roof, and we'll do this. Okay, and we'll have a grids of 5 meter length, and total will be 20 meter in both the directions. So we'll do this, and there will be 1, 2, and 3, and 4 number of floors. So we'll insert below, and the spacing will be minus 1.9. Okay, this one, and we'll insert above, and this will be, we'll do TOS, this also TOS. Okay, spacing here will be 3 meters. Okay, 3 meters. So this is 0. This is the plinth level, this is the base, and this is the ground floor. Okay, so we'll insert above 1. So this G plus 1, G plus 2, G plus 3, and okay, uh, G plus 4. So we can see here like 4 stories we have made here. So first of all, let's finish this and then we'll see. Okay, so TOS means top of steel and TOF means top of foundation. So that's okay. Remember to press OK. If you don't press OK, just press the close, then nothing will be saved. So press OK. And if you want to see whether the changes you've done are OK or not, go to structure window and then open the levels, and you can see any one which you click. Okay, double click and this will open. Suppose I want to open the foundation, double click on the foundation or B1, this will open. Okay, this is the structure 3D. So we'll go to the plinth level of the structure base and we'll work here. So we'll go and create the grids here. So for that, we'll use a rectangular wizard, and whatever the name, we don't care really. And here, this 4 number of base will be there in the x direction, and length will be 5. And next, and here also 4 and 5 meters. Similar we'll do in the y direction. Next, and if you want to rotate, you can rotate and then click on finish. So this is the grid here, which you are seeing in the plinth level. So we can go to the foundation level as well. Okay, this is the foundation level, and you can also go and move the foundation level from here. Okay, and then we'll place the columns. So for the columns, we'll take this column. So now you can see and choose various sections here. I'll go. You can just click here, new, and you can choose from the various sections which are available. So I'll go with circular hollow sections here, and we'll choose a circular hollow section. So let me choose here 300H1, okay, for the columns here, and click on select. So you can select this, and if you just click on the grids or just drag, you find this circular columns. You go to the structure, I'll find this circular columns. You can also see this, zoom in and zoom out like this. Okay, so you can see that along the base plate this appears. So no problems in that. And now you can in the 3D view, you can rotate with the help of right click. Hold the right click for mouse, you can rotate this. So now you can go forward and select all the supports, zoom in and zoom out, select all the supports. So all the supports have been selected. Now make them more or less fixed. So fixed support denote the monolithic connection between the footing and the column. So that's why you choose the fixed supports to get some moments. So fixed supports has been selected. So round or circular columns, and then you go to base, the plinth level, which will actually do our business here, and then we select our beams. So for the beams also, you can select any section which you want. Not gravity only, unselect this. Okay, any section which you want, and in this section we'll go with our circular section as well. So circular section, and we'll go with, let's say let's go with 200 H4. Okay, and go to select. By the way, you can also change the grade here, grade of the steel here. This is Fe 410. You can change this also. Okay, so suppose you want what it is, it is advisable to maintain a single grade. Suppose we in this project, let's go for Fe 540. Okay, so just select this, and these will be done. And for the columns also, I'll just change the grade to FP540. For that, I'll just select the columns here and I'll change the grade here. What's the grade? 300 to FP540. So similar grade is preferred for the analysis. Okay, obviously. So this is done. So once this is done, now we can create some infills, right? So to create some infills, we'll go to the structure base and we'll go to edit and we'll go to create infills. So here by number, you just click on 4 and you select the type. If 540 is good, okay, and you just select the sections which you want, okay, ISMP or circular. So I'll go with circular. You can go with circular here also, okay, RHS or follow, okay, IJS. So any section you can go with this, okay, and then just click on select, okay, and then you just select the entire span and which direction. Suppose I want in this direction and click here, or if I want in this direction and click here like this. So let's go in this direction. So like this, you can see infills have been created. Now the comes from the deck slab. So steel welding, let's create a slab here. So you can create the general steel deck. Okay, general steel deck. You can create this slab, and you can see 100 mm depth. So let's give it 150 mm depth here for the steel depth. And as usual, we'll keep all our project to FP 540. Single span is better. So I'll select this and then you will assign this steel deck. So you can see the steel deck has been assigned to the plinth level. Generally, we sometimes ignore this, but since it's a composite building, we have also provided the plinth level, the base. So you can see this is the at the plinth level it is provided. Now, if you want to copy this, we'll just simply go to one and click on this base, and then all this we can do as base, right? Click on OK. So we can see how easily we can do this. We use the option translation repeat in StatPro. Here it is like this in StatPro. Okay, so go to construction levels and make them back as unique. So it is very important step. Otherwise, you can do not do any unique changes in any of the flows. So you can just click on OK. So again, you can check back that all are unique or not. It's a very important step. So you can see all are unique now. So now this model has been completed this one. Now we want to insert the truss. So for now we'll insert the next step for the next level 2.4. Okay. So we'll go to construction levels and create another level, and this time we'll give the spacing as 2.4. Okay. Click on OK, and we'll select the end of this columns here, these columns, and control, okay, control and select these columns. Sorry, I didn't press control, I pressed shift by mistake. Okay, now it's okay. And then in the top level, you just change it to structure 6. So it goes up, as you can see, as easy as that, it goes up. Now we'll create another level. So we'll create this level. So this level is 1.8 above this. Okay. So we'll create another level, construction levels. Another level will be set above, and this will be 1.8 meters. And then click on OK. And then to this level, we can draw by using frames. So go to frame, and you can just simply click on the grid line. Suppose this grid line, and then you have this grid line, and you have this grid line, and you have this grid line. So then you open this frame and you can just select it. So you can see A, B, C, D, E, F, G. So suppose I'm choosing frame A, and then this appears, and then just draw a random beam here, random beam just like this, so that you can get a point of intersection, and then we'll take the beam, and let's see, as usual, we'll go with FP 540, and here section is a hollow section. Okay, hollow section, and this hollow section, let's go with 300 H2. Okay, select and select this, and select this again, and then select this. Now escape and select this and delete. So like this we can do, and for this particular you can see here like this. Go to structure 3D. Okay, so click on escape here, and for these particular middle columns, we can just extend this like this, select this, and topmost level, top level, just do it maximum one, structure 7. So it will be like this, right? Okay, and I think this two went by mistake to the top level. These two group. Press Control and bring it to the lower level, top level as structure 5. Okay, so this is good here now. Yes, this is good. And all these columns were not selected, I think. Select this and select this. Okay, so and then the topmost level will be this one, structure 6. Okay, so now we can copy this, right? So select this and then select this, and then we can copy this. So go to edit and select the copy, and then select this, this, and this, and then close this, and then go to model and click on beams. And now I need to join these portions. So take this middle portion and then join this like this. If this is joined wrong, take this, then again beam. So like this we joined with our beams here. I think we can copy this also. I'll try to copy, otherwise I'll sign. I think we can go to edit and let's try copy this from here to be careful, here to here. This is copied with these. So let's validate the model, just to check the model and validate. Yeah, we have some errors here. Node collision. Let's see where the node are collided. And member collision also is there. Okay, so member collision is there. So I'll just delete the member here. Okay, now let's validate. So it's okay. So I think I have placed the member twice here. So that's why the member collision. So that's an important check which you need to have. And now we can place some bracings. So for that, I'll go to this two portions will provide the bracings. This is 5, grid number 5 and grid number 1. So we'll go to home and just click on this frames. Frame number 5. We'll select this and we'll go to model bracing and express. Okay, I can select again the column grid and the section also. So like this you can provide. Okay, so you can select this and you can go to edit and go to copy, and you can copy this. Okay, so again then just select this, control and select everyone, the bracing, and then copy, and then alternate spans to press the bracings here like this. Okay, so since we went in frame 5, so then we'll go to frame 1, the opposite side, that is. So again, model bracing 1, 2. Make this 540, 540. Then click here, click here. X brace is not selected. Okay, so sorry. So X brace selected, and then FE 540. Select this, and select this, select this. Now we can select this. Go to edit, copy, Let's copy this. Just wondering if I know just if I placed any duplicate member while doing the bracing. Check here later. Copy this and we'll copy this to this portion. Click on escape, go to structure 3D. Simple to validate because I think that I have made a member collision. Yeah, I know. So, I think I need to delete the member here once. No, yeah, this is the bracing. I need to delete the bracing actually. I provided two bracing here, but without deleting. Select this, delete, select this, delete. Then I'll just select this and extend this to here. Now it should be okay. Let's see. Numeric section. Oh, okay. So yeah, let's just delete this now and go to base, structure base. Have to make this correct. Also select, select, and select and delete this. Okay. Go to beams. Okay. Top view. This is the one, right? This is the one which you don't have. So if I 40, go to structure 3D, validate. Now it's okay. So since I have inserted multiple times the bracings, normal bracing here, that's why this error has had occurred. Okay. So similarly, we can place the bracings in this direction as well. So depending upon where is the opening and all, so you can do that. Now let's provide the go to model and provide the wind panels. So first of all, we'll provide the wind panel here. So here wall panel is there. So I'll show you the tricky side first. This side, 1, 2, 3. You just select this and click on delete. Okay. So wall panel. So we'll select the rectangular portion now for now. Okay. 2, 3, right? And then this one, 2, 3. 1, 2, 3. Again, last one, 1, 2, 3. So like this, we have created our wind panels. Okay. So you can see and check the wind panels like this, right? So wind panels have been created. So let's give the loads here before putting the roof panels. Okay. So now I'll go to load. We'll go to load cases and you can see I'll explain the load. What are the load cases here? So this is the load. This is the self weight of every structure. So this is you can call a dead load, but this is self weight. And this is a self weight of the slab. So this is also a dead load. So these are the other dead loads which will apply like the wind load, like the wall load and the floor finish load, etc. Service load if you want to provide, you can provide. You can also delete this also. If you have service load, then it will take, otherwise it will not take. And then the import load of the live load. Okay. So we'll add another load. This will do wind load, wind load. Here will go, and this will be type wind. Okay. So this will be wind load, which we have added, and then click on OK. Okay. So then we'll put some dead load here. So dead load, and in the dead load, there will be roof panel. So you can calculate the dead load according to the weight of the roof panel. So I am providing, let's say, if the weight of the dead load of the roof panel is 0.3 kilonewton per meter square, and then if you observe the diagram here, then this single line is 10 meter. So 0.3 to 10 is 3 kilonewton per meter square. So of UDL. So we can provide the UDL here. So full UDL and 3. And also remember, in the middle, if it is 3, then at the ends, it will be half. So I'll just explain in a moment. Okay. So here it is 3, here it is 3, here it is 3, and you can provide 3 everywhere, but later also you can change. Here it is 3, and here it is 3, here it is half, like at the end 1.5. So it is 1.5, it is 1.5, it is 1.5 here. Just rotate it, proper view 1.5 here. This is for the dead load, and similarly for the imposed loads also we'll do something similar. So for the imposed loads, let's take imposed load of 2 kilonewton, is zero point 0.2 kilonewton. So it will be 2 at the middle and 1 at the ends. So you can calculate as per the material used, and as per the course you can calculate. So no problem in that. 2 we are providing here, 2 kilonewton per meter, 2 kilonewton per meter, and then 2, 2, 2, and also 2. Another thing you can do, if you want to provide 1 here, you can just select, click on this and assign it first. Okay. And after you assign it, just click on escape and then control and select all the portions which you want to change. Okay. Control select this, and then you do this as 1. Okay. So like this also you can do, like seeing the magnitude has been changed. So like this also you can do. Then I insert the roof panels. Okay, the go to model, and you have the roof panel here, roof panel. Okay, and then you can insert the roof panel 1, 2, 3, and 4, the 5. Roof panel 1, 1, 2, okay, 3. If I double click here, I think it will be done. Double click, yeah, done. You can double click or fifth click at the end. So it's your choice how you can do it. So roof panels and wing panels have been inserted, and now you can go and we can click on validate to check the model if everything is okay. Okay, and then we can go to wind wizard, go to load and go to wind wizard. You will not apply seismic load, you just apply the wind load. Okay, so you can, I'll go with data with each direction. The two possible ways. I'll go data with each direction. Can consider as per your country code. I'm just going as per the Indian code here. The basic wind speed as per the code as per the region you'll do. That's 50 meter per second here, and then click on next. And here there is a table in the IIS code in which according to which you can select the the terrain here. I'll go with open terrain with the scattered obstructions. Okay, so I'll go with type 2 of the code here. So according to which this will take, and the fetch distance is basically the distance at which the wind is the same or the atmosphere is the same. So generally we take it as 5 meter, so no problem in that. Okay, and that the definition of the fetch distance is also given in the IS code, so no problems in that. Click on next, and here if you want to add topography feature, you can add. If any topography hill, you have to give the details, but if you don't want, then you are not required. Okay, then click on next, and then click on finish. So all the data of the wind load it has calculated. This is the beauty of this software. And then we'll add the wind load cases. Okay. CP first of all add for 0, and then just add 4 first, and then do 1 0. One is 90, one is 180, and one is 270. Now we'll change the CP values. So now see along the x is along this direction. So 0 means along the x. Okay, so along the x the CP value 0.8. Okay, so along the negative x direction we know that is the along the windward side, if it is 0.8, then along the leeward side, that is at 180 degree, it will be 0.5. So let's do this 0.5. So now we go along the y-axis. So y-axis also now for the y-axis also the windward side and the leeward side. So the y-axis, there will be a section. So along the windward side minus 0.8, okay, and this one will be minus 0.5. So windward side, leeward side CP applied. And if you want to apply CP more accurately, you can go to table number 5 and 4 of the IS 875, and you can check this. Okay. and then you can click on OK, and then the wind has been defined. Now you need to create some combinations here for the wind, and you can just click on generate and the combinations will be created. Okay, so then click on OK. Combinations have been created, and then you can go to design and click on design all static. So it will take some time, but the design will occur. So as you can see, the analysis is complete, and you can see the pass and the fail members here. So 11 members have failed, and if you want to make it pass, you just select these members, and then you increase the sections, and by interpolation you make them pass. And then you can go also to the review view and check the ratio here. You can see the ratios here. The this color is the most underutilized section, means it will do with lesser section as well. If we give lesser section, then also it will be okay. So all these side beams we can columns we can try give lesser sections. Okay, and red means it is failing, so we have to increase the section for it. So in the below the plinth level, these columns are failing, but above the plinth level it is perfectly okay. And you can see the other results also. You can see the shear force, bending moment, support reactions, and everything. So to see that, you just go, you have this view, various views, your wind view, and then you have the results view here. Third number is the result view, which you can see the shear force, bending moment, and all the other things here. This is the structural view. Come back to the original thing, and you can see the results. And also you can publish reports here, and also you can design the foundation also. So it is pretty similar, but it's the basic process in which you can design the building. And another thing, if you want to provide bracing in this direction also, you can provide, especially in the back direction, you can provide, and in the front direction, apart from the openings or where you will have doors, in those direction you can provide bracings. So it will provide more stability to the structure and protect against the trips and all. So that's all for today. And if you found this useful, make sure you drop a like. And if you want any new videos, make sure to comment. Keep learning. Bye bye.